This is my third trigonometry lesson, and I'm hoping through what you are about to see you can get a better idea of what you're dealing with all these trigonometric equations. Okay. This here is a right-angled triangle. We covered this in Euclid's Elements. If you did not watch my videos in Euclid's Elements, you need to go back to Euclid's Elements and watch all those videos before coming over here, because I'm going to talk about Euclid's Elements in this video. Simple as that. And if you don't know what I'm talking about, you need to go back to Euclid's Elements, learn that, and come back here. Alright. Once again, we have our right-angled triangle. The side of the triangle which is opposite of this right angle is called the hypotenuse. Now, I think most people who take trig know this by now. Okay? So, we have a right angle here. The side that is drawn opposite to this angle right here is called the hypotenuse. Alright, but then we have this little symbol down here. It's kind of an oval with a line through it, a horizontal line through it. And it's called the Greek letter theta. And in trigonometry, the Greek letter theta represents the acute angle of a right-angled triangle. Okay? In a right-angled triangle, you're going to have a right angle, an acute angle, and an obtuse angle. Now, to remember this is real simple. Okay? You stand upright. That's your right angle. Okay? Now, to remember acute, just think of somebody that's physically fit. If they're physically fit, they're cute. Acute. And if you wanted to remember an obtuse angle, well, just think of somebody that's obese. Really obese. Like in 400 or 500 pounds when they shouldn't be. Okay? So, an obtuse angle is a real butt ugly angle, which is great big. And an acute angle is a really nice, slender, athletic, really nice looking body. Okay? So, in a right angle triangle, you're going to have a right angle, an acute angle, and an obtuse angle. Alright, so you have the hypotenuse here, you have the acute angle here, and this is where you start developing your ratios. Okay? Now, I don't know whether I talked about ratios in a previous video or not, but I probably should if I haven't already. But ratios are basically where you have like a proportion. You have like so many eggs to so much flour if you're baking a cake. That's kind of a ratio. The ratio of eggs to flour in a cake. Okay? Or a ratio of how many balls you have as opposed to how many teammates you have in, say, like a basketball game or maybe a golf game or whatever. Who knows? Okay, so say X and Y golf players have X and Y number of balls. That's kind of a ratio. Balls to players. Anyway, in this case, we're going to have certain ratios. Now, I talked about this to some degree in the previous trigonometry lesson. But we're going to go into this a little bit deeper now. Alright, so when you're dealing with trigonometry, you're going to draw a right angle triangle like this. You're going to find the right angle, which is this one right here. Then you're going to find the acute angle, which is the one represented by the letter theta. Once you do that, everything else becomes crystal clear. To find the sine, you're going to find the side opposite the acute angle. Now here's the acute angle. The side opposite would be this one right here. The side opposite of the acute angle. And you're going to divide the number here because this has a measurement. Okay, all three of these lines have a measurement. Okay, this is a certain number of feet or miles or whatever the heck you want to call it. This is a certain amount of feet or miles or whatever the heck you want to call it, so on and so forth. Okay, so there's a measurement of this line, a measurement of this line, and the measurement of this line. So you're going to take the measurement of the side opposite and you're going to divide that number by the measurement of the hypotenuse. Okay, the side opposite divided by the hypotenuse. These are measurements that you're going to take. The measurement of the side opposite divided by the measurement of the side hypotenuse is the sign you're looking for. Okay? Now what about cosine? Well, here's the side here that's adjacent to this acute angle. This acute angle is made up of two rays. This is one ray here, this is one ray here. Okay? So one of the two rays, which is not the hypotenuse of the triangle, so it's the side adjacent to the acute angle here. If you take that measurement there and you divide it by the measurement of the hypotenuse, you get the cosine. Now, what about the tangent? Well, you take the side opposite, which is this one right here, the side opposite of the theta angle. This is the theta angle, this is the side opposite. So you take the measurement of the side opposite of the theta angle and you divide it by the side adjacent measurement. Okay? This is the adjacent side, this is the opposite side. So the opposite side divided by the adjacent side gives you the tangent. Now what about secant, cosecant, and cotangent? Well, on secant and cosecant, you're going to start with the measurement of the hypotenuse. Okay, so that's going to be the top number. The hypotenuse measurement will be the top number in the secant and the cosecant. On the secant, you're going to take the hypotenuse, so you're going to divide it by the side opposite. So, hypotenuse, side opposite theta here, okay, hypotenuse, side opposite theta here, so you're going to divide this measurement by this one if you're looking for secant. What about cosecant? You're going to start with the hypotenuse, and you're going to divide it by the side adjacent. This one divided by this one gives you cosecant. Now what about cotangent? Side adjacent divided by side opposite. This measurement here divided by this measurement here. Now, do you remember in Book 3 of Euclid's Elements when we said that one ray could be a straight line, but one ray could also be a curved line because it was part of a circle? Remember, not all angles have two straight rays. Some angles have a straight ray and a curved ray. And if you don't know what I'm talking about, you need to go back to Euclid's Book 3 and look at those proofs I've got up there. I've got 18 of them so far. I'm going to have another one tonight. Look at that and you'll see for yourself that not all angles contain two straight line rays. Sometimes it's a straight line and a curved line. Sometimes it's two curved lines. So you need to watch out for that. Alright, that pretty much takes care of my trig lesson for tonight. I will tell you more in a future video, so stay tuned.